All right, this is an interesting one. I want to just tell you something conceptually at the start. Um, and here's the idea. They give you the endpoints C and F of this segment. Okay, so if they give you the endpoints, you could do two things with it. You could first use the midpoint formula to find the coordinates of M. That's one step that you're doing. Okay, and then you can take those coordinates and the coordinates of F, and you could apply the distance formula. That's two steps. You calculate that midpoint, then you find the distance between those 2 points. Okay. Another way to look at it, though, and I think a better way to look at it, is because they're not asking what are the coordinates of the midpoint. They just want to know how far is it from the midpoint to F. Well, you already have enough information to find the length of the whole segment. You have C and you have F. That's enough using the distance formula to calculate the entire length of the segment. So how far is it from the midpoint to one of the ends? If you know this, the distance between those, it's half. That's what the midpoint is. So instead of calculating the coordinates of the midpoint, which they're not really asking for, and then applying the distance formula to this point and this point, just do the distance formula to these 2 points and take half of that final amount. That's what I suggest you do. Okay, so I'm going to do it that way just because uh, I think that's less steps and you're answering what they want you to know without having to find out something that you don't actually need to know in order to do this. Okay, what you do need to do though is correctly apply the distance formula, and I'm going to write it: x2 minus x1 squared plus y2 minus y1 squared, and then all square rooted. And that's based in the Pythagorean theorem. I'm happy to talk to you individually and to explain why if you didn't already catch that. But what we're going to do, first step, is always write the distance formula without putting any individual numbers in. See how that first line is just the formula itself? Now I'm going to write the same thing, but everywhere there was a variable, I'm going to put parentheses. That's for x2. That's for x1. And there were already up here parentheses around those two variables. So we need brackets on the outside now. Okay. These brackets just represent this parentheses here because we're putting now parentheses inside to sub in a value. If you don't write these parentheses, I'm just telling you, you're not doing what you need to be doing, and I highly suggest that you do. And I keep saying it over and over in class, but I'm advising you on best way to do stuff. And if you decide I'm not going to do it that way, and you just get lazy, okay, well, don't complain then when your performance is not as high quality as you want it to be if you're not willing to do what I'm telling you to do. So don't forget it. Write the exact same thing over. So here we're going to do it again. That's y2 minus y1. Close the parentheses and square it. I need to extend this over all of that. That. Okay. And notice on the left-hand side that it says D here, but I'm not writing that again every step. The convention with math is that if you just have the equal sign and the blank other side, that this is coming down every time unchanged. Okay. Now, what do we need to do? Well, we need to identify what is x1, y1. This is x1 and y1, because we'll call that point number 1, let's say. Okay, and this is x2, y2. So then when we sub in the points, we say x2 is 5, x1 is 3, and y2 is 5, and y1 is 7. Okay? I didn't need to guess whether I got the negatives right or anything like that. I rewrote the entire formula with parentheses where the variables were, and then I just plugged the numbers in. Now, let's start to simplify it. You should be simplifying this. Every step should be one thing that you did simpler, and the rest of it all stays the same. So we say 5 minus 3 is 2, so we're going to say parentheses 2, and it's squared. And you do want the parentheses there. Trust me. plus, what is 5 minus 7? It's negative 2. This is a good example of why you need the parentheses. If you don't put the parentheses around the negative 2, it means something different than if you did. I'll talk to you more about that in class. But then, how do we simplify 2 squared? It's 4. How do we simplify negative 2 squared? Also 4, because you always get a positive number when you square. And then we say, okay, that means 4 plus 4 is 8, so the square root of 8. And what is the square root of 8? If we were to break this down, it would become 2 times 2 times 2, right? That's the prime factorization of 8. And then our rule says, if you see it in there twice, you can then bring it outside once as a 2, right? Whatever you crossed out twice inside, that's what you get on the outside once. So we get 2 root 2, or 2 times the square root of 2. Okay, that's the distance from C to F, and I could write that as C to F without the bar over it, means the distance between points C and F is 2 root 2. So if MF is half of that total distance, then what's half of 2 times root 2? Well, 1 times root 2. And 1 times root 2 is just root 2. We just call it root 2. That is this right here. Okay? If you had gone and did it the other way and found the actual coordinates of M and then applied the distance formula, then the distance formula would have spit out root 2, and you wouldn't have to take half of it because you've already just going from the midpoint to the one end point. Okay? I think my way's quicker because you're not doing the calculate the midpoint coordinates and then apply the distance formula. It's just apply the distance formula. I think it's better. Okay? Good luck.